All right, 3 assignments for today. Pythagorean theorem. All right, to find isosceles triangle side lengths. So all these are going to be isosceles. These are going to look a little funky at first, right? Here's the idea. You're trying to figure out this entire length of the triangle. But in reality, what I want you to do is ignore this for a second and just try to find the length of this little part of this leg here from this newly made right triangle, right? So we have split the triangle in half, and now our triangle looks like this. We have 12, 15, and x. Now remember, we got to label these as A, B, and C, right? A and B form the right angle, and C is the other one. And if we're using Pythagorean theorem, just like we did last time, we would say this: A squared, which is x, B squared, which is 12, equals C squared, which is 15. All right, so we got x squared plus 144. Remember, I'm squaring these, equals 225. And then if I subtract 144 over this way, I get 100 and... Whoa, my fault. That ain't right. We get 81, excuse me. 81. So then what's x? X is 9, right? Now, is our answer 9? No, it's not 9, right? This is 9. This little piece is 9. In other words, we rewind it back to the beginning. We just found out that this little portion from here to here is 9. So that means the whole thing is 18. Okay, in this one, we're going to do it all the same way. I'll get you started. Except we're not going to have to double our answer at the end. This is x, and it's the same as in the drawing, right? We didn't replace it with something new. The only thing new will be that this is now 3, right? When it says 6, it means this entire length is 6. And then you'll have to set it up this way, and I'll let you guys solve it from there. That equals 8 squared, excuse me. All right, and you'd solve it from there. Now, let's do a different assignment. What we're going to do is we're going to check and see which 3 numbers, and it could be all of them, which of them would form a right triangle. So here's what we're trying to do. All right, let me skip to the last one. So letter C, I'm just going to do that first. If I do the 2 smallest sides, 30 squared, plus 40 squared, I'm going to ask the question, does that equal the same thing as 50 squared? If the answer is yes, then it's a right triangle, right? What we just did was the Pythagorean theorem, and that is only true in right triangles. So this would be 900 plus 1600. That adds up to 2500, and guess what? Guess what 50 squared is? It's the same thing. So if both sides match, we have a right triangle. All right, let's look at letter A here. So you might be asking, what about letter A? If I square the first thing, what does that mean? What's the square root of 4 squared plus 10 squared? Well, this is just 4. When you square a square root, they cancel each other out. And then we're left with 4 plus 100, which is 104. Then ask yourself this question: does 104 equal 116 squared? No, this is some insanely large number, right? 104 is not equal to 116 squared. That's enormous, right? So it's not A. How about letter B? 3 squared plus 6 squared. What's that? All right, so that's 9 plus 36. 9 plus 36 is 45. Is 45 the same thing as the other number, 8 squared? Well, no. 45 is equal to 64. No, that's not correct. So C is our only correct answer. All right, the last assignment is going to look like this. It has a bunch of squares, and you're going to do pretty much the same thing. But these are already squared units. It's here to make you visualize a different way to see the Pythagorean theorem. So this is a side that's already been squared because it's talking about the area of the square formed by the side of the triangle here. So if we made a square that was that same width, or that same length on each side, we'd have 35. Now that means it's already been squared. So we're just going to say 35 plus 50. 35 plus 50 is going to equal this. And it's asking, what is the area of the square adjacent to the third side? Well, that's Pythagorean theorem. We just add these up. We get 85. Let me do one more of these for you. Just the same idea. 13. And those units have already been squared. But I want you to notice the difference. The difference here says, what's the length of the side? So if we add those two up, let's look at what we get. All right, 42 and change, so 13 plus 29.25. The problem is that's not our answer. That's the area of the square formed here. So what we'll have to do on this one is we're going to have to take the square root. It's not asking about the area the same way the last question was. So let's take the square root, and there's our answer, right? 6.5. That's all.